All right, it's time for our water vapor condensation investigation part 2. So right here, I have a steaming cup of water. You might be able to see gas come out, maybe not. So what I'm going to do, I have a dry container of water. There is nothing in here. Can you all confirm that this is dry? All right, so what I'm going to do is I'm going to pour this hot water into this bowl, and then I'm going to close the lid. Let's make some predictions. What do you think is going to happen? What will you see? What will happen to this container? Let's go ahead and watch. So I'm pouring the water in. Whoa, 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 whoa. All right. And now I'm going to close the lid. What is happening? Look at this, it's kind of springy now. What is happening? If you said condensation is happening, you would be absolutely correct. But how is the condensation forming inside this container? How is there condensation inside this container? All I did was put hot water in here and close the lid. There's nothing cool in here. Remember last time we put ice in a cup of water, right? It was cold. It was cold water, and it was forming on the outside of the glass. But I poured warm water in here. So how can condensation happen in this container as well? So I'm going to go ahead and lift this up so we can get a good look on the inside. All right, we have proof that condensation is here because if I go like this, I'm wiping away water droplets. There are water droplets on the inside. So, how did we get condensation? This container, when it was empty, was at room temperature. We put almost close to boiling hot water in here. And I closed the lid. We saw a few processes of the water cycle happening. We saw that the warm, close to the hot water started to evaporate. When it evaporates, right, that's liquid turning into a gas. In this instance, it was turning into water vapor, right? Water vapor is everywhere around us. It is around me right now. And it was when the water was evaporating in this container, it was turning into water vapor itself. But we know that condensation occurs when water vapor or a gas comes into contact with a cool surface. It condenses and turns back into water droplets. So what happened with this container is, like we said, when we started this container, it was very cool. We poured hot water into here, but the sides of the container were still cool. No hot water had touched them. So when we put the lid on our container, all the water vapor started to go up to the lid and it was trying to escape. It even kind of domed out this lid. It became puffy because all the gas was collecting in here, building pressure, trying to escape. So there was water vapor in the air. But so there's a water level, right? There's liquid level. So everything above here was not in the contact with the warm water. So the lid portion of the lid up here was cooler than the water. So again, we have a cooler surface. So the water vapor is coming into contact with a cooler surface, which is forming condensation, which allows the water vapor to condense on the sides of the wall. Because it's hot down here where there's water, but it's cooler up here, which means the water is going to condense, the water vapor is going to condense on the sides of the container. Science!